Now we're going to do two-step trig with law of sines. So for this problem, two fire towers are 40 kilometers apart. Tower B is due east of Tower A. A fire is spotted from both towers. From Tower A, the fire is 21 degrees northeast. So I'm going to put my 21 here as if it's my angle of elevation. Then from Tower B, it tells me that the fire is 38 degrees northwest. Find the distance of the fire from the line connecting the towers. So it's asking us from the line connecting the towers, it's asking us for this side to the nearest kilometer. The other thing that we didn't label yet in our picture is that the two towers are 40 kilometers apart. So I'm going to do this and put my 40 down here. Okay, now for this type of question, we cannot use trig. I don't know that that line that's connecting the two towers is equidistant or equal distance between the two. And actually, we can tell it's not because those two angle measures are different. So instead, what I need to do is I need to use law of sines. Now, to use law of sines for this one, I'm going to find two triangles. And the two triangles that I know about, or the two triangles that I'm going to use, one of them is going to be this big triangle. And the way that I know that is because the biggest triangle there, I know the bottom of. And I always need, for law of sines, to know a side of a triangle. So the bottom of that triangle is 40. This angle here is 21, and the other angle in the other corner is 38. This is going to help us because I can now find this missing angle here at the top. So I'm going to add up the two angles that I know, and I'm going to subtract that number from 180. So I get 59, then I'm going to take 180, subtract 59, and I get 121. So now I can set up law of sines to find either of these two opposite sides, opposite those angles. And it's up to us which one we find. We can either find this side or we can find this side over here. And it's up to us. It doesn't matter. Either one is perfectly fine. So I'm just going to put my x back over here. And I'm going to use law of sines. So law of sines says that the sine of an angle, so the sine of 121, oh my goodness, it's lagging. Let's try that again. The sine of 121 over its opposite side is equal, or is in the same ratio as the sine of another angle over its opposite side. And again, we're looking for opposites. So I'm going to use the sine of 38 because it's opposite the side that I want. Then I'm going to cross multiply. So when I cross multiply, I get 40 times the sine of 38 is equal to x times the sine of 121. And for some reason, the ends in sine don't want to show up, so I'm just going to rewrite those. Okay. Now, again, we're just doing law of sines. So we're going to divide both sides by the sine of 121. And I'm going to type this into my calculator in 2 steps or using alpha y equals. And I get x equals 28.7300 ... Okay, so now that I found that this side, I'm going to look back, is 23 or 28.3. I'm going to write that in my picture here, 28.7300, blah, blah, blah. Okay, now why do we care? We care because now that I know that side, I can look at this right triangle here. So I need to use one of those two right triangles to help us find my ultimate x, or we could put y there, it doesn't matter, that we're asking for, because we're asking for this side. So now I can take this side, put it right there, and I know that this angle measure here is 21. All right. Now I'm going to use SOHCAHTOA. So looking at this, I see that it's just sine. So it's the sine, oh my goodness. Here we go again. Okay, sine of 21 is equal to the opposite side over the hypotenuse, 28.7300. Then I'm going to cross multiply. So 28.7300 times the sine of 21 is equal to y. And again, in my calculator, I'm not going to rewrite that decimal. I'm just going to continue to scroll up and then highlight it. So I get 10.2959. And that's my final answer. So now that I have my final answer, I'm going to round to the nearest kilometer. And to the nearest kilometer, that's about 10 kilometers. So sometimes we get questions like this, where we have one triangle that is not a right triangle and one that is. And sometimes we have ones like here on this next page, where we also have one that is not a right triangle and one that is. But instead of being overlapping like they were a minute ago, here they're just next to each other. So let's look at this one. Kathy wants to determine the height of a flagpole shown in the diagram below. She uses a survey instrument to measure the angle of elevation to the top of the flagpole and determines it to be 34.9 degrees. She walks 8 meters closer and determines the new measure of the angle of elevation to be 52.8 degrees. At each measurement, the survey instrument is 1.7 meters above the ground. Determine and state to the nearest tenth of a meter the height of the flagpole. So here's our height of our flagpole, and we're going to put an X over here because that's what our ultimate goal is. Now, in this case, the two triangles that I'm talking about are, first of all, this triangle, this right triangle. But the second one that we need to worry about is this triangle. And again, the way that I know that it's this one and not the bigger triangle here, so I'm just going to do that really quick, that big one, is because I know the side of that triangle. And that's always what we're looking for, is what side do you know, okay? So when I draw it out, I'm just going to redraw it. It's a sketch, so it doesn't look perfect. 34.9 is here, and I know that this bottom is 8. On the other side over here, I'm going to redraw my right triangle. Ultimately, I know I'm going to have to use it to find X, and I have a 52.8 degree angle there, but I don't know anything else. So the other thing that you have to think to yourself is, how can I use one triangle to help me find the other? So again, looking at these two triangles, where do they overlap or touch? They touch right here. So I'm going to put a Y on both of those triangles where they touch. And how is that going to help me? Well, now I can find a side of my non-right triangle, my obtuse triangle first, and then I can use that to find a side of the other triangle. So now what we're going to do to use law of sines is we're going to, first of all, find all the angles that we can, especially in the blue triangle. The blue triangle is the one that we're most worried about. So first of all, we have a linear pair. So I'm going to do 180 minus 52.8 to get 127.2. So this angle here is 127.2. Okay, then I can find this angle up top. So to find that angle up top, I'm going to take that 127.2, add 34.9, and subtract from 180. And I get 17.9. So now that I've gotten all of those angles, what I'm going to do is I'm going to set up my law of sines. So for law of sines, we're going to go over here and we're going to do the sine of that small angle, 17.2 over 8, is equal to the sine. And now we have to think to ourselves, which side do we, or which angle do we need? We need to use this 34.9 because we're going to look to try to find y. All right, and then we're going to put that over y. Now we're going to cross multiply. So y times the sine of 17.9 is equal to 8 times the sine, I didn't give myself a lot of room, of 34.8 or 0.9. Oh my goodness, really should move this. Now, to get y by itself, I'm going to divide. And I get y by itself. So again, I'm going to use alpha y equals in my calculator. 8 sine of 34.9. Oops. 8 sine 34.9 over the sine of 17.9. And I get 14.8920. Okay, so again, we love that because now that I have a value for y, I can put it over here in this triangle. And now I'm just going to use SOHCAHTOA, and this happens to be sine. So the sine of 52.8 is equal to opposite over hypotenuse. I'm just going to put the letter y there. I'll put the number. 14.8920. Then I'm going to cross multiply, and when I do, I get x is equal to 11.8619 ... which to the nearest 10th is 11.9 meters. Oh, I also love how there was all this space and I completely just did it all up here. All right. Now, with that being said, try this one on your own. You can check your answer with the answer key